Tad Hogg. I'm from Hewlett-Packard Labs, just a short distance from here. And this presentation actually will follow quite nicely with the one we just heard, looking at some positive uses for these sensors, as well as worrying about their dangers in terms of society and totalitarianism. So the discussion we already heard was basically, as you get advanced technologies, it allows smaller and smaller groups of people to do worse and worse things, potentially, as well as larger consequences for doing good things. But the concern here is that the old defenses that we're used to, both technical and social and institutional, just may not be good enough when you have these new technologies coming along. There's a number of possible responses, and the one I'm going to be discussing is ubiquitous sensors of various sorts, basically making the point that you'd like to have a variety of types of sensors, widely distributed, and so that's in essence the technical end of it, but also in terms of institutional and social aspects, and multiple owners, many people watching whatever else is going on, including the other people with their sensors and so on, so that you have a variety, or a diversity, if you like, of approaches. Now, when we think of what we would like these sensors to do for us, there are basically two kinds of technical ones versus accuracy, that you'd really like them to focus on what are the relevant events. Sensitive, so they can detect small or early versions of whatever the events that might be of concern. But then also a very important social aspect, that the information that these sensors deliver to people who will be making decisions is trusted information rather than more and more spam. So there's both technical and sociological questions here. And so what I would like to do in sort of the next 15 minutes or so is basically look at three different aspects. One is, how do we go about making these sensors? What is kind of the state of the art now and near term? How do we go about deploying these sensors in a variety of ways? And then to turn a little bit to the social and institutional issues, how do we go about using them? And I'm going to be talking about small sensors, which in essence are supplements, not replacements to the kind of large sensors that we're already used to in terms of cameras around and so on. I'm going to be distinguishing two kinds of scales, and in some sense they're both tiny, and sometimes these get all mixed together in terms of what's possible to make now versus what we think we can make in a few years or a ways down the road. But roughly to think of micro machines or microsensors, MEMS is the term that this goes with, if you're familiar with that. Roughly speaking, millimeter scale sensors made out of micrometer, micron-sized parts. Further out, nanoscale machines, which are basically micrometer, that is about the size of cells, of biological cells, sensors, whose components are nanoscale parts. I just want to now show you a little bit of what kinds of things people are able to make. In terms of micro machines, this is a number of examples now from several years ago. Where you see that the tip of the finger up there, it gives you an idea of how big the complete device is. And unlike the focus, what we think of as sensors, say as cameras and so on, these things tend to be more toward measuring forces, accelerations, chemistry. There's sort of a grandiose vision of these this kind of scale of devices. It's called smart dust or motes and so on. This is an artist's conception where you would put these things together in sort of a complete package that would have some power and some communication and so on, and be able to do some kind of monitoring in the environment. Going down by a factor of 100 or 1,000 in scale, there's a lot of current work on nanoscale chemical sensors. These are we're not able to yet put them together into these complete packages, but there's quite a variety of approaches aiming toward basically single molecule kinds of detection of various sorts, much of it oriented toward biomedical applications, but nevertheless would be applicable to looking at a wide variety of chemicals. Now, there's a number of challenges for building and developing these kind of small-scale sensors. A couple of them, very major ones, is how do they get power? It will be passive power, and they can somehow pull out of the environment, or active. Communication, do they communicate with each other, or just say as their owner walks by and then they can download it. But instead of talking about those, I'm going to just describe some a little bit more general kinds of problems or issues that come up with thinking about how we use these sensors. And it's basically because they're living in a very unfamiliar world compared to what we're used to. And so we're visual creatures. We see things, we can hear things. Those are our major senses, the way that we can look at things and detect things at a distance. And that's what cameras will do also. But these smaller sensors are much more like noses. And you think of them that they're detecting chemicals or forces, things that are short range, can be very precise. They can pick out a number of different, very particular kinds of chemicals, very sensitive, but they're not like making an image of what's on the other side of the parking lot, say. Another interesting aspect of tiny sensors is the physics that's relevant for them is sort of what we knew before we went to high school physics. And when you went to high school physics, we learned about Newton's laws of motion and so on. But in the world of these particular sensors, it's really Aristotelian physics. That if there's no forces, there's no motion. Rather that inertia is just not an issue for these kind of devices, especially when we're thinking of the nanoscale ones who are the size of cells, like this bacterium. Their world is very different from what we're used to. Their physical environment, the way they interact with the world, the way they detect things and so on. It's just something that we are not used to, being such large creatures. Purcell has this fun little article a number of years ago on what it's like to be a bacteria or things or organisms this size, which is kind of a fun short read, but also gives you an idea of what the world would be like from the point of view of these sensor devices. So now let me turn to some ideas of how might we deploy these sensors in the world to try to be around and look for a variety of potential threats. The most obvious one is deploy in our environment, and then we'll talk about some other ones that are somewhat less obvious but might be able to give us a lot more sensitivity if people feel comfortable with them. And that will then lead us to the social end of things. So sensors in the environment would allow continual and widespread monitoring, provide the possibility of multiple redundant networks. So you're not necessarily just relying on one central decision maker to collect all this information and decide what it means. And they may, for various reasons, not be able to interpret things correctly, or there might be some disagreements. Or they might even have incentives. If it's just a single source of interpreting, you might have all these widely distributed sensors, but then you go through a bottleneck of interpretation, and they might have reasons either intentional or accidental to misrepresent the information. Now we're moving more and more to a situation where people carry around a lot of electronic devices, say cell phones and so on. And these can easily have additional sensors. GPS, various chemical sensors and so on could be put in these. There you would solve the power problem, that people would carry them around. They would have batteries and so on. They could just monitor what sort of interesting chemicals you come across. And provided you communicate this information around, you then would have a source of widely distributed mobile sensors owned by a number of different people, potentially collected and looked at by a number of different people as a way of getting sensors that move around in the environment. And this could also be in a much more wide-scale version, say if we put sensors in money or any other kind of thing that just is transacted and moved around. The idea of something like this, these kind of mobile devices that carry the sensors around them, is a bit like the way our immune systems work. That you have cells that go around, if you like, looking for trouble, and the important thing is that they get near everything just to see where trouble might happen and not just wait for it in, say, one part of the body for trouble to come. And so something like cell phones or much more like money, that distributes all around among lots of different people, and has the chance to get some of it to get close to whatever it is that might be of concern. Now we go one step further, and when we talk about nanosensors, there are now these devices potentially getting small enough that they go inside our bodies. A primary use, and